Yeah. So Q and WASM. We were very recently started adding very early WASM support to Q. So we want to talk a little bit more about our vision, where we want to go with Q and WASM, specifically because now it's very limited, but we really want to explain where we envision this combination to go in the future. So we need to take a very high level look at Q for that. Of course, everybody here knows how Q works, but we're gonna take a 10,000-foot look at Q anyway before we discuss our vision with WebAssembly. So the first thing we're gonna talk about is what is Q good for, and the way to understand that we need to know what Q means, and I'll go very quick through this. But the reason why Q is so successful and so useful and so easy to use is because Q is very good at representing the structure of data. And more importantly, not just the structure of data, but internal invariants of the data or internal constraints within the data. So it can look from the data not just from the outside, but also essentially from within. And it can look at that with the arbitrary zoom level, essentially, with an analogy. Like if you look at something very closely grained, like an integer, and it's fine. And many other languages can do the same thing. Like that's how we model things in most other languages. But we can be more precise. We can be super precise. Say something is a very concrete thing, like 42, or we can be something in the middle. And it's this fluidity that makes Q interesting, and it makes Q very good at modeling. And of course, people have been modeled all kinds of things in Q. And interestingly enough, they started modeling things we didn't expect. For example, the US tax code. And every day we find more and more things that people find Q useful for modeling. And they do so essentially. They always take they make use of this fluid aspect of Q. So what you see there as policy validation templates and all things like that are essentially the boundaries of those things are pretty fuzzy, and there's like a continuum. It can go from one to another. And but I want to stress out that those things that you can see that are very conceptual things, like what does it mean to be validated? What does it mean? What does it mean to validate something? What does it mean templating? Or what is policy? So we're not thinking of in terms of like JSON. I haven't said anything like Kubernetes or what features Q has. It's purely conceptual things here on this diagram. So the way Q modeling works is essentially the process of modeling is the process of ascribing meaning to data. So we're trying to find what makes data useful and meaningful to us, and what really means that we're turning data into knowledge. And the power of Q comes from the fact that this knowledge is preserved while we do further transformations with the data. And this is really the property that Q is type safe. That's all there is. So Q is, in a way, is not just about data. It's more about integrating and unifying information and knowledge. So the reason why Q is such a good basis to build other systems on is because Q provides the ability to reason and abstract over structure. So if this like one sentence of what Q is, I guess this is my take at it. But nevertheless, all the things so far have been completely conceptual or abstract. But to use Q in practice, we have to look at the pragmatic aspect of it, the tooling layer, what's available for us to work with like day to day. And another reason why Q is so useful, I think, is because Q speaks very different data formats. For example, of course, we know about JSON and YAML, and it's bidirectional translations between these formats, and there are others, and we're adding more and more things. But whereas before, when we're thinking about the meaning of Q, we're looking at conceptual things and abstract things. Now we're dealing with the realities of like day-to-day work, and we just have these data formats lying around, and we have to interoperate with them somehow. And the pragmatic aspect of Q is essentially that it provides the ability to abstract of a data format. So we only need to care. So to abstract means to eliminate irrelevant detail. So in this case, the irrelevant detail is the specifics of the data format, like JSON or YAML or anything like that. What we're really concerned about is like the information contained within, specifically in like a meaningful form to us. And the foundational aspect of Q that we first saw in the first part of this presentation, the rich data model of Q is so rich that it enables us to essentially translate any sort of other data format into Q and preserve its internal meaning and its internal invariance. So Q provides the ability to abstract over data format, and it's absolutely crucial to using Q, and it's extremely useful. And it kind of provides us data format independence, although it's not quite 100% perfect abstraction, because if you look at the things like JSON and YAML and all the other things that you can convert to or from, essentially are files or like file-like objects, or in any case static data. So if you're using the Q API, of course you can get some sort of dynamic data from your program, but nevertheless, it's then you basically you lose the command line interface, so you already do something. But nevertheless, like foundationally, these sort of things that Q operates on that are from the outside universe are static in some sense. So Q doesn't really have the ability to consume data that's not essentially in some sort of file, which is interesting. I mean, it's not, you know, let's look at it some more. Another limitation of Q is that encodings, like for example, the translation to JSON, to YAML, and so on, are essentially implemented by us. They're tied to Q. Of course, we're adding more and more, but fundamentally, we cannot never support all of them. And more importantly, again, there's no user level support. So of course, if you use the API, you could write your own translator, but then again, you lose the command line interface. And even so, you might not be able to do it anyway, because the way translations happen now, they're purely textual. So you have to have a finite amount of information that comes in and translate it to some finite amount of Q, which might not always be possible. Like, for example, the data model of Q definitely supports things like infinite lists and things like that, but there's no way to express them in Q actual source code. So if you have some sort of infinite data stream or something like that, that in principle, like semantically, you should be able to operate on, even if you write your own encoding, you will not be able to do it. So this is one limitation that Q currently has, which is let's call it an accidental limitation or something we didn't fix yet. Another limitation Q has, which is definitely very intentional this time, is that computation in Q is very restricted. And this is a very useful feature, like, because we know exactly the type of computation that can happen in Q. Essentially, we can evaluate Q in finite time, and we can provide all sorts of guarantees about Q evaluation and things like that. So this is a very good thing. Nevertheless, people do yearn for more computation, and they try to create their own functions, sort of with the in and out pattern that you see there, which like it definitely represents like a need, and users, and the way we try to make this a little more easy in Q is that we have a relatively rich standard library, and we tell users to reach the standard library if they need computation. But then again, like the standard library is just what we thought it's useful. We do not have user level function support, so it's like just what we provide. And sometimes you just need more features and some sort of computation that's not available. So in summary, Q currently has abstraction of a structure, which is the same thing as saying abstraction of a types. It does have abstraction over some data formats, specifically the ones that we implemented ourselves. But it does not have abstraction over arbitrary data sources and formats. Especially it cannot deal with dynamic sources of data. And again, it does not have abstraction of computation, because computation is basically just built in at the moment, so you cannot write your own computations. So keep this in mind when we talk about WASM, and specifically our vision of Q with WASM. So we think of Q and WASM as being like a sort of unifying framework, or unifying tool, or unifying abstraction that essentially connects completely independent sources of data. And of course, we can already do that with JSON and YAML as we've seen before. But we want to extend this to dynamic sources of data, and more importantly, user-defined sources of data. And I'd like to give one example with authorization systems, because this is something critical in every organization. Everybody has their own authorization system, and everybody has already written the code that deals and and uses the authorization system. And it would be very useful in Q, for example, to just write some policy code in Q that makes use of the authorization system. And currently, there's no way to do that. The only way to do that would be like to literally just dump the data from the authorization system as a static thing and plug it into Q with the API. But we don't want to do that. We have like want to maintain this. We just want to be able to refer from within Q to dynamic source of data, essentially. So now Q is great because it can express static and known relations between different sort of objects, and it can enforce all kinds of properties and invariants. But ultimately, some relations are simply too complex or dynamic. So Q as a modeling tool essentially means to abstract over the rest of the universe, find what kind of useful property we care about, and model it in Q itself. But sometimes we just have to make use of external relations that we cannot express in Q itself. But fortunately, any sort of external relation is just a function, because a function it's just a specific case of a relation. And fortunately, functions are computable. So they're computable objects, so you can implement them in some programming languages and things like that. So what we really want for Q is that we wish to be able to call into external code, even preferably code that you might have already written. And again, every organization uses different programming languages: Go, Rust, C, whatever. So we need to support all that. So we want to call into external code essentially just like we call into the standard library of Q today, and these functions should be used exactly the same way as you use functions in the standard library today. For example, they can act as validators. I wrote a function called isAuthorize, which does what I just explained before. But you can just essentially shell out to do expensive computation. For example, the Ackermann function is very computation expensive to compute. So coming back to the earlier slide, we need to modify it a little bit somewhat. It's not that we just want to relate sources of data. We really want to relate more complex and dynamic systems. So general systems and problems in general. And essentially, with dynamic relations, we just defer to external sources of computations, external sources of code that compute the functions and so on. So in this interpretation, you can think of Q as being like the center of truth that shell out or like spans or finds, relates different computations. You can think of it like a scheduler or things like that, which brings us to the analogy of Q being kind of like a spreadsheet, where Q values are essentially cells, and you can refer to them they can refer to themselves and have constraints and things like that. But you can also call into functions defined in external languages, which perform complex computations and things like that. But more importantly, also like external data sources, which are defined by the user. So things that we haven't, we didn't add special support for, but the user could add their own support if they need it. So just some information about WebAssembly. What exactly is WebAssembly? In its fundamental form, WebAssembly is just an instruction set for a virtual machine. So you can think of it like a JVM for Java or the CLR for the .NET ecosystem. It's a stack-based virtual machine. It's a stack-based instruction set just like Java, but unlike the other ones, it's much smaller and far more principled. It's formally specified, and the specification is machine checked. So any new update to the WASM standards and so on is machine checked, not just tested, or just we have a strong proof of its correctness, basically. And I say that it's typed. It is typed in the sense that we have some basic types. Currently, we only have like integers and a couple of types like that, but it's typed in another sense. It's guaranteed to, for example, being a stack machine. It's guaranteed to never blow the stack or never do a stack underflow, overflow, things like that. So basically, it's those properties you can get by being very, very well specified and having validators for the code you load and things like that. You can see a function on the right. It doesn't matter what the function does, but here is a more complicated example. So in WebAssembly, you don't have just functions, but really what you have is like modules. And they use this interesting S-expression syntax for specifying everything in WebAssembly. So you have modules, and in modules, yeah, functions, of course, have code and stuff like that, but you can export functions. And those functions that are exported from WASM then can be called from essentially the outside, from the host or from the runtime, which can be written in, and the host can use them, even though the host and the compiled module use different languages. Although more on that later. So WASM is more than just like an instruction set. It's really just a technology which has multiple implementations. For example, every modern browser today ships with the WASM implementation, and they're very different runtime implementations, like WAS0 and WASMer. And these implementations are written in different languages. For example, we use WAS0 because it's written in Go and has no dependencies. But everyone comes with their own trade-offs. But the idea is that there's like this not collaboration, but like maybe even competition between runtimes, and people try to drive the ecosystem forward. And also, most major tool chains target WebAssembly. For example, Rust and Go. Go very recently added support for WASI, which is the actual standard that we're using, which makes available Go to Q now in some sense. But many languages can compile to WASM. And even more importantly than that, maybe it's like WASM is not just a simple specification. It's an evolving standard that there are many extensions and many improvements that are debated and implemented, and essentially lots of competition and lots of activity happening in the WASM space. And people have built businesses on top of WASM. And essentially, it has a very positive vibe in the industry. Everybody seems to like it. So, us participating, we see that us participating in WASM as being a very good thing, because we take advantage of all kinds of innovations that other people have already implemented or done for us. But we can also like drive the ecosystem forward if we need to. So for Q, WASM makes the perfect sense, because as I somewhat alluded in the formal specification of WASM, these plugins are safe. So we know that it's safe to load them dynamically at runtime. It will not explode our program, because we can have plugins, for example, implemented the shared libraries and things. But then basically we lose safety, and we also lose portability. So you can compile almost any language, not quite, but enough languages to WASM, and we could use those modules. And again, we don't have to worry about like low-level details, like what architecture are running on and anything like that. So we gain portability in that sense also. And also, again, like unlike the JVM and all the others, WASM has a super small footprint. It's also pretty performant, by the way. It's not usually WASM is not interpreted. It's actually ahead of time compiled, so you get pretty good performance. And the industry coming with plugins and other companies that do plugins and things like that, they seem to convert to WASM. So we think that they makes perfect sense for us. So the way we envision Qt and WASM to work together is super simple. It's people just write, or ideally even reuse code that they have already written in any language, like C or Rust or Go or anything really. And just by magic, really, the code simply becomes available to call from Q. Now we're thinking of providing some level of tooling, which is minimal and very easy to integrate into your own CI or however you compile your code, that makes it all work. But essentially, we think that all the low-level details of the Q to WASM interaction are taken care of by Q, so the user doesn't have to think of any of this, any of the low-level details. The user just takes their code or writes new code, and by typing, I don't know, Q build or some other command like that, it just becomes available to Q. Another thing that we're thinking of is, because WebAssembly is essentially a compiled format, so you have to compile it, and then you have to distribute those WebAssembly modules somehow. We are thinking of using the Q modules, the Q module ecosystem, the Q module infrastructure, as a distribution mechanism for WebAssembly modules. So if you use WebAssembly in your application, so if you want to export to the rest of the ecosystem a Q module that just happens to use WebAssembly internally, or maybe you want to make that explicit, essentially that should be supported. So if you just build your WebAssembly module, then it should be just picked up by the Q module system, and a downstream consumer of your code wouldn't have to know anything about it. So the Q module system would completely subsume anything, all the details about the WASM distribution. We're not going to talk about the Q modules now. There will be a separate talk about Q modules, but yeah. So how do you actually use it, WASM with Q now? Well, first, just a caveat. We have to quantify what we just said. So our vision for Q, what we just said, is aspirational. We're quite far from it yet. So we really think as the tooling as being like a very foundational part of it that makes it easy for people to use WebAssembly in Q, but we don't have that yet. So it's all manual. So the ergonomics of using WASM they're not great. And currently we can only exchange very basic data types between WASM and the host. Also, this is a feature, of course, that WASM now is completely sandboxed, but we wish to restrict that in some capacity at some point. Relax that in some capacity at some point, because ultimately, as I said, if you have like a code that is tied into your infrastructure and has to do network flows or whatever, we want to support that, maybe not by default, but in some capacity, and that is not supported yet. So modules are completely sandboxed and have no access to the outside environment. But nevertheless, like a lot of people use Rust these days, so let's see how we could actually make this work in Rust. So for Rust, it's quite easy because the Rust targets, it's very easy to add a new target to a toolchain. So assuming you have Rust installed, essentially you just run the first command over there, which will install all the toolchain necessary to compile to WASM for us, for Q. There are other WASM targets, but this works for Q. And then you can either create a new project or reuse your existing project. But whatever you do, you must make sure that you're compiling essentially to a shared library, because that's what WebAssembly modules are. So you need to change that in your build configuration. And then you can just build and specify the targets that you install above. So it's super easy to do in Rust in terms of the tool chain. In terms of the code, this is an example. This is some code example. We're just having two functions here. The first one adds two numbers. The second one checks if a number is prime or not. But you can see it's like there's a lot of extra syntax and noise that you have to put there, unfortunately. So let's look at that a little bit. So the first one, no mangle annotation. Rust has annotation kind of like the same way that Q has annotation. So that's a signal for the toolchain, for the Rust toolchain, that when they compile this code, they should use the same names for the function exported outside the module as they use in Rust. So add and is prime. Otherwise, they would use some internal Rust name. And unfortunately, we have to put that now. For now, we also have to put this extern C. Extern C basically selects the ABI used by the code, which is the C ABI, which is an ABI that's it's the only ABI really that we have common between all the supported languages. But also it comes with the limitation that we can only pass very simple data types back and forth, essentially just integers and floating point numbers and booleans. So yes, so the programmer has to do those things for now. But how does it look on the Q side? So on the Q side, you write your Q code in the same directory as the WASM compile code. So the first thing you have to do is you have to put a package level annotation that essentially informs Q that WASM is available, or they should use WASM. So this is at the package level, and then to import specific functions, every function that you want to import has to have another external annotation, which specifies the first thing you need to specify is the WebAssembly the specific WebAssembly module that exports that function. And for here we see that we use two different modules. Another thing that Q needs to be aware of is the ABI. Currently, only the C ABI is supported, but it has to be explicitly put here anyway. And the ABI-C is the same thing as this extern C here, so it has to match in that sense. Of course, we will add more ABIs as time goes on. And if you want to rename a function, for example, you might want to use idiomatic names in the host and in the WebAssembly module. For example, Rust uses underscores, but in Q we use like a camel case, I think we call it. So you can rename functions that way. But of course, most important thing that you have to put in external annotation is that the actual type signature of the function that you're interested in. And we use this syntax for type signatures. Currently, we only support this syntax inside external annotations. We will eventually have native types, native function types in Q. So you instead of the top type there, you could just put the function type. But for now, you have to put it in the external annotation. And as I said earlier, they're just only integers and booleans, and floats are supported for now. But we wish to extend it to everything else in the future. So how does it work? Then basically it just works. Functions work just the same as standard library functions. They just get called in the same way you expect. You can even print the names, and you can see there the distinction between the Q name and the internal name used inside WASM. And yeah, functions, yeah, they work. But we're very limited now. So our primary concern is supporting richer data types. Eventually, we want to support any data type that Q supports. So we will be able to pass any sort of Q data back and forth. As an intermediate step, we're going to support JSON. So we're going to have an ABI JSON. And we're going to add many different ABIs, which may make things more convenient for one language or some other specific use case. But in the general case, we want to support every data type. But also, just as important, we're adding tooling that makes things easy to use for the user. So we don't want users to have to write these essentially Q annotations that describe the exported interface of a module. Rather, the tooling, when you type Q build or whatever you want to call it, they would generate all this for us, and they would ideally generate it from the code itself. So the code in Go, in Rust, whatever, already knows the function signature, so we should just be able to use that essentially. Another thing we're working on is a correctness detector. So the functions that you call from within Q have to respect certain properties. For example, there's no they shouldn't use mutable state. They should always give the same answers to the same questions. There's no way to correct that, to enforce that statically, but we could have like we're working on dynamic detector that would try to detect violations in sort of the same way as the Go race detector works at runtime. And as I already mentioned, we're adding function types to Q, so everything will be syntactically clear. Most important thing now that we are actually looking for is feedback from people that are using WebAssembly, or they want to use WebAssembly. We know that a lot of people have proprietary code, and they try to tie Q into their infrastructure, which involves proprietary code. So we're looking for public feedback. But if you want to have like a private chat with us about specific needs, we're also very willing to do that. Thank you. So that was it with WASM. So any questions now? I think there was some.
There's a few in the Q. Yeah, there's a few in the Q&A.
Constructing Q values programmatically is also a little difficult at the moment. Yes, it is.
I don't know where were you reading that question from? This.
That was from the chat. Yeah.
Oh, okay.
Right.
If you go to the Q&A, George and others have asked a couple of questions in there, which are probably worth starting with.
I did go to the Q&A, but I see no questions.
Oh, I can see them. I'll read George's out. Unless George, do you want to ask you the questions live? Go for it.
Yes, I got really excited to ask them before actually Aram answers some of them. So like the first question was about like how Q values will be serialized, because now you can just do that using strings, and this will be difficult to pass it to WebAssembly functions. Yeah.
So we essentially we're looking at abstracting this from the user basically. So essentially you would use whatever data type is most convenient for you in your language, say Rust or C, whatever language you're trying to use, whatever is most convenient, that still can represent the data contained in the Q value. And we in the tooling layer or in the glue layer would would deal with all the serialization, all the marshalling, and everything like that. So essentially, it should be transparent for the user, and we should use that's why we want to. We could have a very general API that supports everything, but we probably would be slow because that's the support of data labs. So that's why we're thinking of having multiple APIs. Because for specific sort of data that you want to pass back and forth, we could have a more efficient one. But all of this, we think of all of this as being like hidden from the, or not necessarily hidden. I mean, you can always do this manually, but the tooling layer should take care of all the details basically for you.
But it will always have to be concrete data types, so we can't pass on like
we haven't
constraints or like type definitions.
We haven't yet. We think in the general case you should be able to pass any data type. We haven't fully made a decision on that yet, but in general, we're kind of pretty sure you should be able to pass anything. Yeah, which actually, if you use, once we add once we make the Go support better, one major problem with that is that in the target language, you also have to have a Q support. So that would work for Go, because Go, you can just use the API from Go itself. But for example, for Rust, we do not have a Rust API for Q. So ideally, we want to support that. So that's the main reason why we're thinking it's difficult, because we would have to support, for each target language, we would have to support essentially a Q API. But we will definitely do it for at least a couple of the popular languages like Rust.
Yeah, because like my second question is actually about that, like how to share type definitions between WebAssembly and Q, because this is a really great use case. Because whenever you write WebAssembly and trying to run it within a different runtime, you have to redefine the types twice inside the WebAssembly code library and inside the program that's to run the WebAssembly functions.
So we're thinking that the tooling layer would be bidirectional. So if you already have code in Rust or Go, say, that uses those native data types, that the tooling layer would take care of the translation to translate those things to Q, but also the other way around. So if you just have a Q, because for example, if you just import a module from someone else, but you want to use WebAssembly with that module, we're thinking of the tooling layer as taking that Q and generating native data types for your program also. Yeah, Paul.
Just to build on that, because I think there are two parts to that question or answer, if you like, George. At the moment, we have Q get Go, which is a command that allows you to take Go types and create Q types from those definitions from them. That is only one way at the moment. We want that to become a fully symmetric thing as much as it's possible, because of course you can't always faithfully represent in one language what you can in the other. So QGetGo will actually be renamed to QImportGo. And one of the most requested things is people being able to generate Go code from Q types. So then really you don't care where your source of truth is, whether it's the Go code or Q. So that gives you the native or the language specific type declarations. Just to build on your answer on so that works if you've got concrete data. If you don't have concrete data, you need the answer that Aram was talking about, where we have the Go API with the Q.value type. Your language would need to have something like that for those incomplete, non-concrete types, not least because of references and things like that. So it's a sort of fuzziest picture, but if you've got some familiarity with the Go API, if you then sort of project that to other languages, but also then take QGetGo and say, okay, let me rename it QImportGo and QExportGo, and then substitute whatever language you want there. Aram's slide earlier on, where we've got translation between concrete data types, then fully extends to languages where we've got concrete data, then extends to languages that have the concept of types as well. And if Marcel's already done an experiment in this as well, the concept of constraints that are like sort of error checking also becomes feasible at some stage as well. But that's, yeah, as Aram said, we're starting small and building up from here.
Cedric?
Hey, I kind of wanted to ask more about the long-term plans for using Q using WASM and Q together.
Yeah.
So I think the idea of it making sense, writing functions and then using it in the Q code to transform data, but flipping it around, it seems like being able to use WASM with the Q package manager and such, that we could also use Q as a kind of like to orchestrate basically different polyglot languages or functions together for new kinds of programs. Is this something that the team is thinking about, or like what's the long-term goals here in terms of what we can do now that we have this capability?
Well, if I understood your question correctly, I think let me go back to a slide. I think that's kind of sort of like the spreadsheet model,
Right.
Where you would define a code in any language, of course, and you would tie them together by Q, if I understood that correctly. That's definitely something we're thinking about. Yes, we definitely want to support that use case, and we're thinking that's a good use case, because then you would have like a separation. You'd separate and delineate very clearly what are the static properties that can be enforced and reasoned by in Q, which are simple things, but and then you defer actual computation to more appropriate languages. So we think of this as being we think this is the best way to combine Q and other languages. Really, that's what we think about, because it makes the distinction between what can be statically known in Q very distinct. So yeah, I think so. I think we do.
Yeah, and that's what I was thinking about when you talked about that spreadsheet analogy. It seems like kind of like a new kind of application, like not generally starting with the general purpose, but you start with like say like the structure in Q, and then you're composing the actual computation to do the thing. Maybe also talking about like compute management itself too, to actually make that happen. But yeah, just wanted to know more about the thinking there.
Yeah. I mean, already if you use Q, for example, to do container orchestration, it's kind of like that. I mean, it's not about the dynamic data. Then it's about just managing containers, but it's sort of the same idea as Q being the how can I call it? Yeah, Q defining the structure, the high level structure of the thing, and deferring to lower level details to other layers, essentially. Yeah. Herman? Yeah.
Oh, sorry. Just before, sorry, Herman, I'll come to you in a second. The one thing you talked about in the slides is the maintaining the hermetic nature of Q. Is it worth just sort of touching on how, because Q has Q command, or what we refer to as the tooling layer at the moment. Is it worth just briefly talking about how WASM might fit into that picture there? Because I think that touches really on Cedric's point, is that if you want to call functions that do have side effects but use Q as like an orchestrator, then you need to break out of that hermetic ceiling in a certain way. So
WASM by default is very well sandboxed and restricted, so you cannot get outside the sandbox. But of course, there you can open holes, or you can open access to the outside on a per need basis, very granular, basically. So we're thinking that by default, you would get essentially a sandbox, but in the tooling layer, or maybe with the explicit user's consent. So the user would know when this happens, essentially. In some context, then the WASM code would have essentially access to the outside universe. And because we have the distinction now between, let's call it pure code and the tooling layer, we could do the same. We can do this distinction in the tooling layer, or maybe there's another better place to do this distinction. Yeah, I think Herman had his hand up first.
Yes, thanks for your presentation. It's packed with information. So, my question was about the WASM component model, which is quite novel.
Yeah.
It's quite new. It's somewhat related to Cedric's question, maybe.
Yeah.
Is that something that is considered, will be supported in the future?
Yeah, we are looking at that. It's essentially we're looking at, the thing is, so there's a very different, so different WASM implementations support different features, and more importantly, features that are now being worked on have very different support and different implementations. So yes, we are looking at the component model, and we want to move in that direction. But I think at the moment it's quite far in the future. So once it becomes more accepted, or yeah, we definitely are interested in that. Yeah.
Okay, thank you.
Yeah, Roger.
Yeah, I just thought I'd just add a little bit to the thoughts about side effectful computations, and one possible way forward with that would be that you could potentially avoid the WASM layer entirely, and in the way that currently the tooling layer is kind of orthogonal to the queue interpreter, and you can look at aspects of the queue and sort of fill it in with your own information derived with respect to the information you already have, and sort of fill that in. The same could happen with function signatures. So when you see a function call and you're like, okay, this is a function call that I understand, then I can get the parameters for that and I can fill in the results. And that doesn't necessarily need to go through WASM. It could be just in your Go program, for example, or in anything that's interpreted in the queue. And I think that's potentially like a really powerful and sort of complementary way to the whole WASM way of doing things.
Just my thinking on that, just to add to it, is that one of the nice things is the WASM piece gives you that cross-platform aspect. And so if you've got this way of building a cross-platform tool that is language agnostic, that you can easily distribute as a queue module, etc., it's that I don't know, that's an interesting space. But Rog, totally take your point.
Yeah, and another thing that we could possibly do is we could add a capability system that essentially then it's the user's responsibility to give very specific outside access to WASM, essentially. So WASM, the user could control exactly what the WASM code could do, because the code would not have access to anything else that the user provides it with.
Yeah, I think there's kind of two different possible scenarios going on here. Right? One is where the queue is driving things, and another is where a program is sort of driving the queue, as it were. So the program has access to this queue and knows how to do things within itself. And I think that both of those are legitimate ways of looking at the queue.
Yeah.
And in the former case, you probably don't want to have to go through the WASM layer because you already know how to do stuff within your own program.
Sure. Yeah.
The way, just for the sake of, just say this, the way I'm seeing functions as a kind of conceptual thing in queue in general at this point is like a function is like a gateway through to something outside queue. It's just conceptually, it's a bridge from queue into the outside world in some respect. At the moment we've got the standard library, which has lots of Go implemented stuff. It's nice and hermetic, but essentially it's something outside the queue model, and that's the way I see functions fitting into queue in general. We already have this model going on, and we're basically just increasing the scope of that model.
Yeah, and just to add to that, by default, we always want to preserve hermeticity and things like that. So it's always going to be some sort of the user has to know when things can break this property.
Yeah, I'm not even sure about that, because where we have the tooling model, the results of the tool invocations are by definition not hermetic. They might make HTTP calls.
Yes. But
so we definitely don't want to say that all queue code and all functions will always be hermetic, because that's definitely not the case, right? I think in the long term, for WASM, I think that we definitely want that to be the case, because these things we want to make it available to arbitrary queue interpretations. But in the general case, maybe not so much.
I think I don't know what Aram was probably going to say. What I was going to say there is that the user should be aware.
Yeah.
Whether there can ever be side effects, because it's I think particularly of like a policy engine, for example, where you absolutely do not want any side effects, right? Is that it's almost a critical property of the policy engine that it should not be able to have side effects. And so just being clear that there are these different, I don't know what the right word is, lenses or whatever modes, not quite sure what word to use, in which Q can be used and in which it can do this orchestration and come up with answers, it is, I think, going to be useful. But Rog, in saying that, I fully take your point that in the general case, there will be situations where people do want the side effects. It's just they've got to be clear that's what they're getting.
I totally agree, and I think like preserving that very, very strong distinction between hermetic and non-hermetic is absolutely crucial to what happens with Q in the future. And I think that like the sort of capability model that Aram alluded to is, where you actually explicitly pass down capabilities and they don't go into any code that you don't see, is perhaps a really interesting way forward there.
Herman, I had a question, if you don't mind, about your question about the component model. Could you just talk a bit more about the use case that you had in mind there, if you're still on?
Well, I have ideas for use cases, so no specific one, but I like the idea of being able to compose multiple WASM programs as a pipeline, basically, so that you can, combine them in interesting ways. And I have some ideas where I could use that. So, yeah.
So we wish the component model was more was already accepted or widely available, because another property that it has is that it deals with the API issues, essentially binary, it deals with binary, specifically the binary format of data passed around things, which is exactly what we need to make Q plus WASM more useful. So yeah, we really want to be like a part of the standard, really. So yeah.
We had another question coming in earlier on. It's somewhat related by virtue of the word WASM to what it is you presented around. But folks interested, and this question has come up a few times, in how Q could be used in an environment like AWS Lambda, or at the edge, or whether it be function-based environments. Do you want to just talk a bit about that, because there's a sort of few overlapping answers to it? Aram, did you hear that?
Yes.
Okay.
Yeah, sorry, I thought we were waiting for George.
No, that was a question from somebody else, not George. Yeah.
Okay. Yeah. So the thing is, Q already can be compiled to WebAssembly. For example, this is how the Q playground works. So if you are in an environment where you want to run Q at the edge and you are expected to provide a WebAssembly thing, you can definitely do it today, although you would have to use the API basically, because it's just the way it is. But then again, using the API means that in your program you can do absolutely anything you want. So we don't have any sort of specific special support for any of that, but it's possible. One limitation, however, with WASM is that in that environment, you would not be able to dynamically load other WASM modules, because you cannot run WASM in WASM, essentially. That's the problem. So yeah, you would do something there, but other than that, it's perfectly supported, and yeah. Jan?
Yeah. Hi, Aram. So you're saying you cannot include recursively do WASM, but you can't compose it somehow. I mean, that's
yeah, you can. Depends. For example, in the playground, the main problem is that you're tied to a very specific WASM interpreter, the one in the browser, which has very limited set of features. So in some very limited sense, maybe you can do something, but in the general sense, no, because what we provide for example, so the WebAssembly standard that we're using for in Q is called WASI, and it's not the same one that's used in the browser. Basically, it's a different one. So yeah, you need a different WebAssembly standard, and then you could maybe do something like that and compose them. But yeah, in the general sense, that's the main problem. That in the browser we have a much restricted environment. So
Yeah.
yeah.
And these cloud environments use those browser engines, you mean?
Yeah, I'm not sure exactly what they use in the browser engine, but then again, it's the problem then becomes that, so the way you interact with WASM from Go is very specific to the WebAssembly engine that you're using. So if you use a different WebAssembly engine, you have, so
It's from Go, yeah.
so currently we only support WAS0. So if we want to support one of the cloud ones, it will have to be specific support per cloud, basically, you know, or maybe they use an open source engine and then we can just support it. But it can be done, but it has to be done on a case by case basis. It cannot be done just generally.
Yeah. Okay. Well, it's just theoretical question, of course. It's
Yeah.
not...
Yeah.
Thanks.
Yeah. Yeah. Well, if there not any more questions, I think we can wrap up. We finished on time.
Thanks everyone for joining.
So yeah, thanks everyone for joining.
Thanks, Ron.
And if folks want to, around one thing to probably mention is the umbrella issue for WebAssembly. We should, let's try and dig out a link to that. Or at least I'll tell you what we can do. We can post a link in the YouTube recording so that folks can subscribe to that to stay up to date with the latest on the WebAssembly side of things.
Yeah, and again, like if anybody wants to chat specifically about anything, in private or anything, we are available.
But
Rachel?
like, okay.
Oh, sorry, no, go for it.
I was asking, like, what can we do to help?
Well, I mean, if you have just chatting or talking, especially in the GitHub issue, if you mention your specific use case, that would help a lot. Yeah, just specific use cases, how you want to use it, or feature requests or anything like that. Because we have lots of features planned, but again, I think if people talk about it, it would help, like with prioritizations and things like that.
Absolutely, that point on prioritization, absolutely key. So I think, again, if we then break out specific bits and pieces, like if somebody has, I'll just make up something totally random. If somebody wants to use it in kind of to build on Aram's example earlier on, but build out a system that uses queue in an RBAC or access control type scenario where there needs an access decision needs to be queried by some external via some external API, very specific use case, very specific goal, that's solving that specific case might help to flush out design issues or whatever. So that kind of thing.
Yeah, I will post in this chat the link to the WASM umbrella issue. There's no information. It's just an umbrella issue, but yeah.
Thanks, everybody. Thanks, Aram.
Thank you. Bye-bye. Have a nice day.
Bye-bye.